Everything around us is made up of elements, or different types of atoms. While these atoms are way too small to see, if you break an object or organism down enough, ultimately everything is made up of these tiny particles. And although your coffee table or textbook might seem pretty stable, some elements break down over time, including some that make up the objects in your house. These are radioactive elements, meaning that they break down over time by releasing energy and turning into different elements. Let's look at how this process happens. All atoms consist of subatomic particles like neutrons, protons, and electrons. Neutrons and protons make up the nucleus or core of an atom. Electrons float around the nucleus in a cloud-like structure. The number of protons in an atom determines the identity of the element. Each atom has a set number of protons and neutrons in the nucleus, but sometimes there are more or less neutrons than usual, which make the element an isotope. Elements can be distinguished from isotopes by their mass number, or the total number of neutrons and protons in an atom. If there are more or less, the isotope will have a different mass number than the original element. For example, normally carbon has 6 protons and 6 neutrons, giving it a mass number of 12. The isotope carbon-14 has 2 extra neutrons, making the isotope carbon-14. Some isotopes are unstable and release neutrons, protons, or energy as time goes on during radioactive decay. There are 3 main types: alpha, beta, and gamma decay, which we'll discuss next. Alpha decay releases the largest particle during radioactive decay, which consists of 2 neutrons and 2 protons. This type of decay ejects the subatomic particles very quickly, which can damage our cells if they get into our bodies. However, since alpha particles are very big, they don't get too far and are easily blocked by our clothing. When an element undergoes alpha decay, it releases protons, which turn it into a different element entirely. Beta decay occurs when one neutron ejects an electron and becomes a proton. Alpha decay often creates unstable isotopes that also undergo beta decay. Beta particles are a bit lighter than alpha particles, so they can go farther and penetrate materials deeper. However, clothing will still stop beta particles. In gamma decay, no particles are released, but the isotopes formed by alpha and beta decay still have too much energy. The energy is released as gamma rays. These rays penetrate the farthest and can even go through a foot of concrete. Gamma rays are very damaging to human beings. Radioactive elements are everywhere. Here, we'll go over a few key examples related to energy production, archaeology, and medicine. Uranium, U-235, is the main element used in nuclear power. In huge reactor cores, U-235 is bombed with neutrons. As a result, the unstable isotope undergoes alpha decay and splits into new elements. As the protons and neutrons separate from the original element,